All right, we'll take a look at Think Central Lesson 112, attaching the information we have been studying in this unit to real-world problems, basically word problems. As with any word problem, the most important thing to do is unpack it and draw a picture, illustrate the problem, and come up with a model to help you solve the problem. They're asking us to enter an equation where h would represent the number of miles Harry ran. So we have a variable h. Ariel ran 5 1/4 miles on Saturday. This is 2 3/4 miles more than Harry ran. How far did Harry run? So first thing we want to do is come up with a model to represent the problem. So I'm going to use a comparison bar model to help me solve it. This represents the 5 1/4 miles that Ariel ran, and this amount is more than Harry ran by 2 3/4. So 2 3/4 miles. This would represent how many miles Harry ran, because this number here is 2 3/4 more than what he ran. So I'm comparing Ariel to Harry, and I know the difference between those is 2 3/4. So what I don't know is I don't know this amount here, what he ran. So using my model will help me. I have Harry. In this case, Harry's here, in this amount here. So Harry, which is that, plus the 2 3/4 miles that I have here, so that number will go there, will equal the amount Ariel ran, which is the 5 1/4 mile. All right, once we've set up the equation now, we know that h plus 2 3/4 is going to equal that. So now we have to solve for h. The way to do that is, so if h plus 2 3/4 here equals 5 1/4, then 5 1/4 minus 2 3/4 will give us h. So we're going to go ahead and subtract, take away 2 3/4 from this side, and take away 2 3/4 from this side to solve for h. It's called isolating the variable. Setting up the problem vertically at 5 1/4, I have minus 2 3/4. I don't have enough quarters, so I'm going to go ahead and rename this 5 as 4 4/4, giving me 5/4 over here. 5/4 minus 3/4 is 2/4, which can be simplified to 1/2. 4 minus 2 is 2. So the amount that Harry ran would be 2 1/2 miles. And the final part of it is the answer is reasonable, because 5 1/4 would round down to 5, and 2 3/4 would round up to 3, and 5 minus 3 would give you 2, and 2 1/2 is very close to 2, so it is a reasonable answer. Problem number 2, they're going to ask us a problem where W would be the variable. The beach is 7 1/3 mile from Joanna's house. She walks part of the way, and then she takes the bus the remaining 5 7/10 miles. How far does she walk? So it's probably best to start off with a picture. Here's a very fancy picture of Joanna, and she is going to walk to the beach. So over here, here's the beach. There's a wave, and that total length is 7 1/3 miles. So she's going to walk part of the way, and we don't know how far that is, so that is unknown, and we're going to use a variable W to represent that. And then she's going to take a bus the rest of the way, and the bus is 5 7/10 miles. So this is your classic part-whole model. The total would be 7 1/3. Part of it is 5 7/10. The other part we don't know. So finding the difference between 5 7/10 and 7 1/3 will give you the answer. So that's one way you could do it. Situation equation. A solution equation would be W here plus 5 7/10 here would equal 7 1/3. So if you're going to write these in, it would be W plus 5 7/10 equals 7 1/3. So again, as in the previous problem, you're going to subtract or find the difference between 7 1/3 and 5 7/10. So I've drawn the problem vertically. I see they're unlike fractions. I'm going to use a common denominator of 30 for this. So to get equivalent fractions, I'm going to multiply 7/10 by 3/3. Give me 21/30 and 1/3 by 10/10 to give me 10/30. So I'm subtracting 10/30 and 21/30. I don't have enough 30ths, so I'm going to have to rename this fraction, adding 30/30 to this number right here. So that would give me 40/30. 40/30 minus 21/30 will give me 19/30. 6 minus 5 is 1. So the actual distance she's going to walk is 1 19/30. Is it the answer reasonable? 7 1/3 would round to 7. 5 7/10 would round to 6. So the difference should be about 1, and as you can see, the difference is very close to 1. So that is a reasonable answer. Okay, so I've set up my problem with a model. Nora read 1/7 of the book on Monday, 2/5 on Tuesday, and unknown amount to be read to finish the book. So all three of these together have to equal 1, the whole book. So we just need to find out what is the difference between 1 and 1/7 and 2/5 combined. So I've drawn my problem horizontally. I've found equivalent fractions. Used the denominator of 35. 5/35 and 14/35 gives me a total of 19/35. So now I know that the 1/7 and the 2/5 of the book combine to 19/35 of the book. Then how much would I need to get to finish the entire book? 35/35. And so we have 1 whole minus 19/35. 1 whole is the same as 35/35. 35/35 minus 19/35 would give you 16/35. So that is the difference that she needs to read in order to finish the book. That's how much is unread after she reads 1/7 and 2/5. Solving the second part of the problem, 1/7 is close to 0. It's a very small fraction, and so she's read about half of the book, and she has about a half to go, and 16/35 is very close to a half because 17 1/2/35 would equal a half, so she has about a half left to go. And the final problem is a word problem, and it's always best to draw a picture and a model to help you understand the problem. Anna hikes 3 7/8 miles, stops for lunch. Then she hikes another 2 1/4 miles, stops to rest, and then the sign says it's another 1 1/2 miles to the end. They want us to know what is the total for all of the hikes. So we're just going to combine 3 7/8, 2 1/4, and 1 1/2 to get our answer. Alright, I've written down all my add-ins vertically. You notice that they are all unlike fractions, but all of the denominators have a multiple of 8. 2, 4, 6, 8, 4, 8, and 8. So I'm going to use a common denominator for all these of 8, which means I don't need to change the top one. That turns into 2/8, and this one turns into 4/8. So I'm going to add up 7/8, 2/8, and 4/8. Alright, 7 2 is 9, and 4 is 13, so I end up with 13/8 as my parts, and 3, 2, and 1 makes 6. So the answer is going to be 6 13/8, but I can simplify this. 8 goes into 13 one whole time. There's 5 parts left over, 1 5/8. So I add my wholes over here. So that's going to give me 7 wholes, and 5/8 is the total distance for her hike. And is it reasonable? Well, 3 7/8 would round to 4. 2 1/4 would round down to 2 wholes, and 1 1/2. I could just leave that the same because I don't need to round that one. So 2 4 1/2 would be 6 7 1/2. 7 1/2 miles, and you can see 7 1/2 is very close to 7 5/8. So the answer is reasonable. All right, that's working some real world problems. Probably the most important part of that was drawing models and pictures to represent the problem to help you understand it. Make sure you're asking for help because it's going to build mastery. Great job, everybody. See you later.